Thank you for giving us this opportunity to present our research work in this conference. And thank you everyone for joining this presentation. Our research work is on enhanced removal of ciprofloxacin from aqueous solution using a chemically modified biochar derived from bamboo sawdust, adsorption process optimization using response surface methodology. This is a part of a PhD dissertation by Wondimu, a Ph.D. candidate in Africa Center of Excellence for Water Management at Addis Ababa University. And this dissertation is being supervised by Professor Junwoo Kang and Dr. Batalay Takola. Pharmaceutical micropollutants are one of the emerging contaminants of current environmental concern that have been detected in wastewater, surface water, and even in drinking water across the world. They are detected in the range of nano to micrograms per liter. Among the pharmaceutical contaminants, antibiotics are the most widely consumed pharmaceutical drugs that pollute water bodies. Under antibiotics, ciprofloxacin stands in the first place based on the number of antibiotics prescribed in this group. Our research work focused removal of ciprofloxacin from water because of its wide consumption as a broad spectrum drug, and because of its incomplete metabolism that is 15 up to 50% excreted unchanged after human consumption, and because of its higher environmental concentration and frequent detection in the environment, we targeted removal of this contaminant from water using biochar. The release of this contaminant to the environment causes water contamination. The water contamination causes health effects on humans and also development of antibiotic resistant genes as a consequence of release of this contaminant to the environment. Therefore, research is required to deal with this contaminant, with this environmental problem. This contaminant, ciprofloxacin, is difficult for conventional treatment system because of biodegradation resistance. As a result, different techniques, different treatment methods have been developed by various scholars to address this problem. However, still, there is issues associated with safety, efficiency, and sustainability, and also the cost among the developed techniques for the removal of ciprofloxacin from water. As a result, research is still going on. To this end, we modified biochar chemically, which was synthesized from bamboo sawdust collected from local areas, low-cost and waste material, for enhanced removal of CIP from wastewater. The research objectives include biochar preparation, modification and characterization, adsorption process parameter optimization using a response surface method, and also study of adsorption kinetics, isotherm and thermodynamics, and lastly, regeneration study of the material synthesized in this work. Overall, goal is to have enhanced removal of CIP from water. Adsorbent preparation methods is presented here. Bamboo sawdust, which was collected from local areas processing bamboo for different applications, and the collected bamboo sawdust was ground to a particle size of less than 450 micrometer, and after that, it was treated using ferric chloride and potassium hydroxide chemicals in 5:1 and 1:5 ratio under heating and stirring in a magnetic stirrer. After that, the chemically treated bamboo sawdust was dried in vacuum oven at 60 degrees Celsius. And after drying the bamboo sawdust, the dried one was ground to particle size of 150 micrometer and then carbonized at 700 degrees Celsius for 1 hour at 10 degrees Celsius per minute rate. And after carbonization, the biochar was ground to 150 micrometer and made ready for the subsequent adsorption study. Here comes adsorption method, how the adsorption experimental work was conducted. Here, CIP solution containing ciprofloxacin, pure ciprofloxacin, plus adsorbent was placed in a water-based shaker for the adsorption process. And after that, the analysis of residual CIP was done using UV-Vis spectrophotometer. When we come to the results and discussion, it includes characterization results and adsorption process results. And before going to the detail of the adsorption process, adsorbent screening test was conducted previously to have or to select the best adsorbent. And the adsorbents considered were unmodified bamboo biochar, the raw biochar, ferric chloride only modified bamboo biochar, potassium hydroxide only modified bamboo biochar, and ferric chloride plus potassium hydroxide modified bamboo biochar, the combined modification, and tested on ciprofloxacin removal from water. And as you can see here, the unmodified raw biochar gave 45% removal, and the combined modified one gave 96% removal, which shows the modification significantly increased the surface property, the surface area and functional groups, and then that resulted in higher removal of CIP. And MBC, this combined modified one, was selected and used throughout this research work. Here comes the material characterization technique, FTIR analysis. And this one you can see before modification, the FTIR spectra of unmodified raw biochar is like this one. After modification, you can see here different functional groups were emerged, and these were very important in adsorption process. After adsorption, as you can see here, some of the peaks has been disappeared, and the peak spectra has been shifted, which shows proper adsorption of CIP was taken place onto the modified bamboo biochar. And another one is XRD analysis of the modified bamboo biochar and unmodified bamboo biochar. You can see here magnetite and hematite were successfully incorporated onto the surface of modified bamboo biochar after modification with ferric chloride. And this this iron species incorporated onto the MBC was responsible for adsorption of CIP through complexation reaction. Another characterization result was PET, specific surface area of modified and unmodified. Here you can see the clear changes between the modified and unmodified bamboo biochar. So the modification has significantly increased the surface area of the biochar, which was very important in adsorption. And another characterization result was 0.0 charge of the material, 6.5, and which was very important during electrostatic interaction because of the CIP property. It has pK values of 6.1 and 8.7, and in between 6.5 and 8.7, the electrostatic interaction was maximum, and higher removal was obtained at that range. Factors considered during adsorption study include initial CIP concentration, pH, adsorbent dose, and time, with CIP % removal as response. The central composite design gave us a certain number of experiments. For each combination, we generated removal of CIP, and analysis was conducted using ANOVA analysis, which suggested quadratic model, and the model was significant, and all the main factors were significant, and some of the interaction parameters were also significant. And finally, we obtained an optimum condition for CIP absorption, which was which is presented like this. The first one is CIP concentration of 20 milligram, adsorbent dose 0.5, pH 7.5, time for 46, removal of 96% was achieved as this condition with a desirability of 0.96. Kinetic models include pseudo first, pseudo second, intraparticle and Illovich model, both adsorption reaction-based model and diffusion-based models. These were the plots for each models with a coefficient of determination R-squared values. As you can see here, the second order has highest R-squared value, and the QE calculated and QE experimental were also well close enough. And then we can say that the second order model best describes the kinetic data. And here comes isotherm analysis result for which we employed Langmuir, Freundlich, Temkin, and Dubnin Radishkovich DR, and the associated parameters were calculated and presented here. The Langmuir with R squared 0.99 and Freundlich 0.97, both models represented the isotherm data well. And another parameters associated with these models are, for example, RL, which is associated with Langmuir separation factor, which is 0.026, is between 0 and 1, which was favorable isotherm. And N in Freundlich isotherm shows degree of heterogeneity, and 1 over N is 0.02, which is also between 0 and 1, which was preferential adsorption. And the overall result of this isotherm analysis indicated that both models describe the adsorption very well, and the adsorption process was favorable. Thermodynamics suggested that the process was spontaneous and increased randomness at the adsorbent interface, and the process was endothermic. Here comes a regeneration study for which the material has 88% CIP removal efficiency after 5 sequential adsorption-desorption cycles, which showed that the MBC was recyclable material and can be used successfully up to 5 cycles. Mechanism of adsorption include pi-pi-ide interaction, electrostatic interaction, hydrogen bonding, ion exchange, and complexation reaction. When we come to the conclusion part, the optimum obtained was presented like this, and the pseudo second order best describes the kinetic data, showing that the chemisorption mainly controlled the process. Isotherm also suggested that monolayer adsorption on heterogeneous surface isotherm results. And the chemical modification of bamboo sawdust significantly enhanced CIP removal. Overall, higher CIP uptake capacity and excellent reusability of the MBC could be a promising indication for the practical applications. When we come to the recommendation part, future works need to investigate advanced oxidation plus adsorption process to have a synergistic advantage. In this regard, ozonation plus adsorption process biochar has great importance, and we are very interested in trying or in studying, investigating this couple technology in the future, and anyone who is interested can work with us. In the future, the performance of this material can be tested for different pharmaceutical contaminants in a fixed bed column absorption process. These were some of the references we used during this research work, and this research work part of the PhD dissertation was published in Adsorption Science and Technology in July 31, 2022. And I would like to thank all the co-authors and the ACEWM for financial support. Thank you, everyone. Thank you for attention. If you have any questions, please welcome.